What if I told you that the biggest discovery in human history might already be sitting inside a sealed titanium tube on Mars, waiting to be opened? Right now, on the dusty surface of the red planet, NASA's Perseverance rover is collecting samples that could answer one of the most profound questions ever asked. Are we alone? Let's pause for a second. For centuries, Mars has haunted human imagination. Ancient astronomers saw its red glow and named it after a god of war. In the 19th century, scientists thought they saw canals, possible signs of intelligent life. That turned out to be an optical illusion. Fast forward to today, and the question is no longer about little green aliens. It's far more serious and far more exciting. We're searching for microbes. Tiny, ancient, fossilized life. And here's the twist. Mars wasn't always the frozen desert you see in photos. Billions of years ago, Mars had rivers, lakes, maybe even oceans. NASA's orbiters have mapped dried-up river valleys and delta formations. The Perseverance rover is currently exploring Jezero Crater, a place scientists believe was once a lake fed by a river delta about 3.5 to 4 billion years ago. On Earth, deltas are incredible at preserving signs of ancient life. That's not speculation. That's geology. Curiosity rover, which landed in 2012, already confirmed that ancient Mars had the basic chemical ingredients necessary for life: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. It also found evidence of long-lasting freshwater lakes, not brief puddles. Lakes that existed for potentially millions of years. Now here's where it gets controversial. Curiosity also detected methane in the Martian atmosphere. On Earth, most methane is produced by living organisms. But methane can also form through geological processes. The strange part? Methane levels on Mars appear to spike and drop seasonally. The European Space Agency's Mars Express and the ExoMars Trace Gas Orbiter have tried to measure it from orbit, sometimes detecting almost nothing, creating a scientific mystery. So what's going on? Is the methane localized? Are we misreading the data? Or is something, possibly microbial, still active beneath the surface? This disagreement is not a failure of science. It's science in action. Now let's interrupt your expectations again. If life ever existed on Mars, it likely didn't look like plants, animals, or anything dramatic. We're talking about microscopic organisms, similar to early life on Earth. On our planet, life appeared surprisingly quickly after conditions stabilized. Some evidence suggests microbial life existed here at least 3.5 to 3.8 billion years ago. At that same time, Mars was wet. Think about that. Two neighboring planets. Similar early conditions. One becomes bursting with life. The other becomes cold and barren. Why? One major difference is Mars' size. Mars is only about half the diameter of Earth. Because it's smaller, it cooled faster. It lost its global magnetic field billions of years ago. Without that magnetic shield, the solar wind gradually stripped away much of its atmosphere. Less atmosphere meant less pressure and warmth. Water on the surface eventually froze or evaporated. But underground? That's another story. Even today, radar data from orbiters has revealed thick deposits of water ice beneath the surface, especially near the poles. Some studies suggest there may be salty liquid water deep underground, although that interpretation is debated. If microbial life ever arose, it might have retreated below the surface as conditions worsened. And that's exactly why Perseverance is drilling into rocks and sealing samples in sterile tubes. These samples are cached on the Martian surface, waiting for a future mission to bring them back to Earth. Here's another pattern interrupt. Bringing those samples home is harder than landing on Mars. NASA and the European Space Agency have been developing the Mars Sample Return Mission, a complex, multi-step effort involving a lander, a small rocket that would launch from Mars' surface, and an orbiter to capture the samples and bring them back to Earth. Due to technical and budget challenges, the plan has been reevaluated, with NASA exploring more cost-effective architectures as of 2024 to 2025. The goal remains the same: return those samples in the 2030s. Why is this so important? Because the instruments we can send to Mars are limited. The most advanced laboratories on Earth are far more powerful than anything we can fit on a rover. With return samples, scientists could analyze isotopes, organic molecules, and microscopic structures in extraordinary detail, searching for biosignatures, patterns that are extremely difficult to explain without biology. Now here's the controversial truth. We might find organic molecules and still not have proof of life. Organic molecules are carbon-based compounds. They can form through non-biological chemistry. Perseverance has already detected complex organic molecules in Martian rocks. That's exciting, but it's not confirmation of life. Science demands extraordinary evidence. A true breakthrough would likely involve multiple lines of evidence, specific chemical patterns, isotopic ratios that suggest biological processing, and microscopic textures consistent with fossilized microbes, all pointing in the same direction. And even then, scientists would argue, because if we announce life beyond Earth, even ancient microbial life, it changes everything. Biology would no longer be a unique Earth phenomenon. It would mean life can emerge independently on more than one world. That dramatically increases the odds that life could exist elsewhere, in the icy oceans of Europa, beneath the surface of Enceladus, or on planets orbiting distant stars. Let's zoom out for a moment. Mars today is hostile. Average surface temperatures hover around -60 degrees Celsius. Radiation levels are high because of the thin atmosphere. Liquid water is unstable on the surface. If life exists there now, it's almost certainly microbial and underground. But here's the hopeful part. We're no longer guessing blindly. We have rovers analyzing rock chemistry with laser spectrometers. We have orbiters mapping minerals formed in water. We have helicopters, like Ingenuity, which completed 72 flights before its mission ended in 2024, proving powered flight is possible on another planet and scouting terrain for exploration. This isn't science fiction. This is happening. And yet, we must stay grounded. So far, no mission has found definitive evidence of past or present life on Mars. Not Viking in the 1970s. Not Spirit or Opportunity. Not Curiosity. Not Perseverance, at least not yet. But each mission has narrowed the uncertainty. Each mission has told us that ancient Mars was more habitable than we once believed. So here we are, in a strange moment in history. For the first time, humanity has physically collected pieces of another potentially habitable world and set them aside for return. Those sealed tubes may contain nothing biologically significant, or they may contain chemical whispers from a second genesis. Either outcome is profound. If we find no evidence of life despite ideal ancient conditions, that tells us life might be extraordinarily rare, even when environments seem suitable. If we find evidence that life did arise on Mars independently, then life may be a cosmic rule rather than a cosmic accident. And that leads to a final, unsettling thought. If microbial life once thrived on Mars and then vanished as the planet lost its atmosphere, what does that say about planetary fragility? Mars is a frozen warning of how dramatically a world can change. The search for life on Mars is not just about Mars. It's about understanding life's resilience, its rarity, and our own planet's future. The next decade could deliver one of the most transformative discoveries in human history. The samples are waiting. The technology is advancing. The question is sharper than ever. So when those Martian rocks finally arrive on Earth and scientists open those sealed tubes, what do you think we'll find? If you're fascinated by the real science shaping humanity's future in space, make sure you follow for more deep dives like this. And tell me in the comments, do you believe life ever existed on Mars? Or are we chasing a beautiful illusion?